Right. Routing concepts, meaning how the packet is moving from one network to another. The concept, the logic, that's what we're going to see in this chapter. Now, initial configuration. See, the routers need IP address. We give IP address on the interface that is connected directly. See, we have done a lab actually. This may be looking silly for you, but let's go through the flow. Nothing wrong, as I said. So we have routers and we have wires connected directly. For that, we give IP address for each wire, for each interface. I'll use the word interface. I'll use the word port. I'll use the word directly connected interface. So this all means same thing, the ports. When we give IP address to each interface, a routing table will get built automatically. What is the routing table? The table which shows the direction and the network. The network and the direction to reach the network. That is routing table. For example, when you're going from Paris corner, you have a signboard. If you go left, you go to Marina. If you go right, you go to Central Station. So this is a router. Marina is connected. This is the road that connects to Marina Beach. And this is the road that takes you to the Central Railway Station, Chennai. So that you can see in that road, in that board, in that signboard, it is written that if you go left, it's Marina. If you go right, it is Central Station. But if you're coming this way, signboard will show if you're going this way, then it is Paris corner. So this board is a routing table. It shows the table, so it shows the route that helps the travelers to take the right direction, right road. Here, road is like an interface of the router, the wire of the router. So this routing table on the router gets built immediately and dynamically as soon as you assign an IP address. For example, here you will say 20.0.0.1/8. As soon as you assign this in the routing table, it will show you connected 20 network. It's network here. Here it is IP. For this IP, no, there it is IP. For that IP, the network only will be seen in the routing table. In routing table, it won't show IP address. It will show network of that IP. You configured IP. For that IP, router knows the network. How? Because you have given a mask. You put 8, then it understands that it's 20 network. Connected via, let's say this is Ethernet 0. It will say it's connected via Ethernet 0. And if you have 10 network here, then it will say connected 10 network via, let's say, Ethernet 1 interface. If this is 30 network /24, you have subnetted and Ethernet 2. So routing table will show you connected 30 via Ethernet 2. This table gets dynamically, 24. What mask you give is what will come here in the routing table. Here I gave 24, even though it is class A, I have subnetted, so I give 24. On the routers, you cannot write like this. You should write 255 0. Must write subnet mask immediately after the IP address. Even if you don't do subnetting, still you need to write the mask. That's mandatory, that's compulsory. Okay, so we assign IP address. As soon as you assign IP address, it comes as a route on the routing table dynamically. Let us see this one and then we'll go to the next level. So I have added some interface. I should be able to join. You see the name here? Gig 0 slash 0 slash 0. You see it is gig 0 here. The first number is 0. But the port that I have connected now, if you see, here it is written slot 1. Okay, it is written slot 1. I don't know whether you can see this. Even I myself cannot see, but I can see that 1 here, number 1. This is 2. In your lab you can see. Okay. Now, why I'm showing you that when you connect wire, it will start with 1. You see, 1 is in the middle. So that middle number represents the slot. The last number represents the port number. In that first slot, this is 0th port. Here, in the 0th slot, 0th port. Here, this one, 0th slot, first port. You understand? Hmm? Now, what we are going to do is we are going to go assign IP address. Surprisingly, this interface is up. How can it come up when I didn't say no shutdown? Anyway, let us go. Wait, I'm suspecting something here. What if it's a layer 2 port that I added? What if it's a layer 2 port? This one. Yeah, I know. It's a switching port. For switching port. We don't want switching port. We want a routing port. Okay, so again I off it. We don't want switching put back. Alright, so what about this? No, this is SFP. Okay, and copper cable link up to 100 meter feet. Okay, Cat 5. Oh, this is SFP base. Okay, for now we'll take 2T serial. Alright. So I got serial, but the problem is if you have serial, you cannot connect through switch. So you can only connect to another router. That's okay. I'll connect the cable. Okay. The problem is in this there is no serial port. The newly added router. Let me add serial port. Of it 2T. Yeah, you see the name serial 0/1. One is slot number, and I'm going to write numbers here for your reference. This is not mandatory. When you do lab, you don't need to write here, but I'm just doing it for a reference. 20.0.0.1, and the mask I'm going to give is 30. Here 10.0.0.0, sorry, 1, mask I'm going to give is let's say 11. Just for you to recall subnetting that you did know, I'm doing this VLSM, variable in subnet mask. And then here 10.0.0. Let us say mhm, mhm, 10.0. 10. I'll say 10. Uh, hmm, no problem. 10.0 or 10.1. No, after 32 will be there. Let's take 64. 10.64.0.1 slash. It need not to be 11. It can be some other number also. I'm going to say 15, or let's say 24. All right. So we have 10 and 20. See, I'm going to configure. One thing we need to be very sure while we configure, we need to make sure that every single interface is in different network. Enable, config T, and then the host name is, let's say, router RT, or let's say router 1, RTR1. Space won't work. You should put hyphen RT space 1. See, I'll try to give RT space 1. See what happens. RT space 1, it is not taking. You should put as 1. And now we have to give IP address interface gig 000. I'm inside this interface. I say no shut to bring the interface up. You see, for security reason, the interfaces will be in a down state. See, router is running, no doubt. If router is not done running, you will not get this command prompt, isn't it? You will not get this CLI to configure. The software has put the port on down state so that without your knowledge, no traffic will enter the router, no traffic will leave the router. So we are telling the software, don't worry, I'm in control. I'm in control. To say that, we say no shutdown. So that as soon as you say no shutdown, you see, first thing is the interface is coming up, and then the protocol also, the protocol that works on the port also comes up. The protocol will come up only if the other end of the wire is ready for communication. For example, if you say no shutdown on one side here in the serial port, if you say no shutdown here, it won't come up with these two lines. Here, two lines are coming up. One is the port itself is coming up, The interface itself is coming up. Another one is the protocol is coming up. But if you are saying no shutdown on serial port, the interface will come up, the first line will come, second line won't come until you go and configure the other side. You understand what I'm saying? Whereas on the switches, all the ports are already active. You don't need to say no shutdown here. I repeat, on the switches, every port will be up. It is not shut down by software. Switches are ready to use, plug and play. That is why they have designed it as active ports, whereas routers are not plug and play. Routers connects many network. So in order to provide some security, safety, the ports are shut down. We need to say no shutdown to bring it up. So when I say no shutdown here, first the port comes up. Second, the line protocol comes up because these two can communicate. The protocols can communicate. But when I say no shutdown here, it tries to communicate, but the other guy is in a shutdown state. So line protocol cannot come up because the other side is in a down state, not ready to talk. You understood this very well? Okay. Let us put the IP address. And it is /11, no? /11 means 255.252.24. Is that right? This is 11. 8 plus 3. If you have 3 bit, it is 224. 128 plus 64 plus 32. Now, did I say here 11? No. I have said 255.224. But if you go to check the routing table, see, I press the button Control Z. You can type end, 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 or you can press the Control and Z button, Control Z, to go to the privilege mode, because all show commands work only in privilege mode. And here you type show IP route. Look at this. I did not give 11. I gave, yeah, it knows subnetting very well. And what is this L? L means on the link. On the link, you can see what is L here. On the link means the local port. This is one local port. This and how many local ports we have? 3 local ports. On the local port, this is the IP configured. Can we have another IP address on the same port? No. That is why it is masking automatically to 32. Meaning this is the only IP address on the port. That is the meaning of it. If it is 32, you cannot have any other IP address. Only one. Fully masked. Fully masked. Yep. Now you see, I am going on the next router. Sorry, next interface. Interface gig 0/0/1. No shut. IP address 10.64.0.1 255.255.255.0. Right? /24 I have given. 255.255.255.0 means 24. Let's go and verify. I'll press Control Z. It takes me to the privilege mode, and I type. What is the command to see the routing table? Show IP route. You can see here exactly the 24 mask is taken, and you see the network here. And this is the IP with the mask. All right. Now I'm going to the serial port, interface serial 0/1/0. I bring the interface up. See, only one line is coming. That also says you changed it into up, but I cannot come up. I'm going down. The reason is the other guy is not talking to me. All right. I'm going to give IP address 20.0.0.1 252. See, I have even given IP address, but if you check in the routing table, it won't come. Do you see serial interface? Do you see 20 network? Do you see? Why? Because if the port is not active, routing table will not say I have a route to 20. போர்ட்டே இல்ல போர்ட்ல இருக்கிற நெட்வொர்க் இருக்குன்னு நீ சொல்லுமா சொல்லுங்க பார்க்கலாம் சொல்லக்கூடாது தப்பு இல்லையா so sometime even after giving IP address the route is not coming in the routing table easy to troubleshoot what is that go and check the link why it is down what is the command to see the interfaces in a brief manner show IP interface brief. If you notice here, the serial interface, you have given IP address, you have even said no shutdown. See, it used to be like this, administratively down. But because you said no shutdown, it has come up, but the line protocol is going down. That is why it is down here. If you go to the other side and say no shutdown, it will come up. Hmm? So let us go to the other side, R1 side, R1. Interface serial. Here it is 0th port. Here it is. Oh, here also one first port. Fine. Serial 0/1/0. No shut. See, as soon as you say no shut here, it comes up. And the second line also comes up because after talking to the other end, it understood that protocol can also work here. I have not even given IP address in this side, isn't it? I'm not given. Now you see that color is turned to green here and go here. And now you can see both coming up. Check the status. Look at this. Up, up. Now if you go to the routing table, you will see the route. You see? Connected on the serial network. This is the network. And this is the IP. And this is subnetted from this network. And these are subnetted from this network. This is the base network. And these are all subnets of that. This is the base network. These are subnets of that. So this is how the routes come to the routing table automatically. Let us go back to our presentation. So we are going to talk about those things in this first chapter. Routing, router initial configuration. Next is routing decision. See, routing decisions are taken based on the route that is shown in the routing table. And also which packet to send out first, which packet to send out next, depends on the size. We'll talk about that when we go there. And then there is encapsulation and decapsulation. See, when a packet is received, you decapsulate or de-encapsulate it and see the destination IP where I need to send the packet. All right. You need to open the packet in order to know the destination to where the packet should go. After knowing, you just again encapsulate it again and send it. And how the path is determined? Using the routing tables info. All those things are going to come in 1.2. In 1.3, we will be learning static routes. See, routers will not have all routes. If you want, you need to write statically. Routers will have only the connected network information in the routing table. The network that are connected on another router, if this router needs to know the route for those networks, either you can write statically or you can enable some dynamic routing protocols. We have various dynamic routing protocols. One is named as RIP, Routing Information Protocol. The other one is Enhanced Interior Gateway Routing Protocol. The other one is Open Shortest Path First. The other one is Border Gateway Protocol. These are all the routing protocols you have. So we will be enabling any one of this protocol to learn the route if you are not willing to write statically. ஒவ்வொரு ரவுட்டர்லையும் போயிட்டு அந்த தூரத்தில் இருக்கிற நெட்வொர்க்குக்கு இது வழியா போ அப்படின்னு மேனுவலா எழுதுனா அது பேர் ஸ்டாட்டிக் ரூட். அதுக்கு பதிலாக கூகுள் மேப்பை கனெக்ட் பண்ணி விட்டுட்டீங்கன்னா உங்க ரவுட்டர்ல ரூட்ஸ் தன்னால வந்துடும். அதுக்கு பேர் டைனமிக் ரவுட். இப்ப பாருங்க, மனுஷங்களுக்கு ஏதாவது ஒண்ணு தெரிஞ்சுக்கணும்னா படிக்க வேண்டியதா இருக்குது. ஸ்டாட்டிக்கா புக்கை எடுத்து படிக்கணும், படிச்சாதான் தெரியும். அப்பதான் எக்ஸாம் போனா பாஸ் ஆக முடியுது. ஆனா ஒரு காலம் வரப்போது, ஓ இந்த குரூப் ஆஃப் ஆளுங்களா, இவங்களுக்கு இந்த வேலையெல்லாம் நல்லா தெரிஞ்சிருக்கணும் அப்படின்னு சொல்லிட்டு பிறந்த சில வருஷங்களுக்கு அப்புறம் மண்டைய திறந்து ஒரு சிப்பை வச்சிருவாங்க. அந்த சிப்ல எல்லாம் ப்ரோக்ராம் பண்ணியிருக்கோம். அந்த துறைக்கு சம்பந்தமான எல்லாம் ப்ரோக்ராம் பண்ணியிருக்கோம். இந்த பையன் அந்த சிப்போட மண்டையில அப்படியே நடந்து போவான். பார்க்கும்போது அவனுக்கு எல்லாம் புரியும், எல்லாம் ஞாபகத்துக்கு வரும். ஏதோ முழுசா வேலை செஞ்சு எக்ஸ்பீரியன்ஸ் ஆன மாதிரி ஞாபகத்துக்கு வரும். அந்த சிப்ல இருந்து வரும், எல்லாம் ரீட் பண்ணும் பிரெயின். அப்படியே பிரெயின்ல லோட் ஆயிடும். அவன் ஒன்றும் இல்லை, அவன் அடுத்தடுத்த ஸ்டெப் தைரியமா எடுத்து வைக்கணும், அவ்வளவுதான். எடுத்து வைக்க அந்த பிரெயின் என்ன பண்ணணும்னு சொல்லும். ஆனா இதுக்கு முன்னால அதை லேர்ன் பண்ணியிருக்கிறானா இந்த புக்லனா? இல்ல. இதுதான் நியூரோ சயின்ஸ். நம்ம தம்பி இலான் மாஸ்க்ன்ற குட்டி பையன் இதுலதான் ஏதோ ஆராய்ச்சி பண்ணிட்டு இருக்கிறாரு. அவர் இதெல்லாம் அச்சீவ் பண்ண விரும்புறாரு. அந்த டெஸ்ட்லாம் கூட பண்ணிட்டாரு நம்ம ஆளு. ஸோ மண்டையை திறந்து அந்த மண்டைக்குள்ள சிப்பை வச்சிடணுமா, அதை பிரெயினோட மர்ஜ் பண்ணிடணுமா. அப்போ சண்டை போடுறதுக்குன்னு சில பேர் பிறந்துக்கிறாங்கன்னா சண்டை போடுற நுணுக்கங்கள் எல்லாம் அந்த சிப்ல வச்சிருவாரு. பஸ் ஓட்டுறதுக்கு ஒரு கூட்டம் இருக்குதுன்னா பஸ் ஓட்டுறதுக்கு சம்பந்தமான சிப்பை வச்சிருவாரு. அந்த வேலையை மட்டும்தான் அவன் செய்யறோம். அப்புறம் மாடு மேய்க்கிறதுக்குன்னு ஒரு கூட்டம் வச்சிருப்பாரு. மாடு மேய்க்கிற சம்பந்தமா மட்டும்தான் புல் எப்போ போடணும், பால் எப்படி கறக்கணும், மாட்டுக்கு எப்படி குளிப்பாட்டணும், இதெல்லாம் அந்த சிப்ல போட்டுருவாரு. அப்போ இந்த பையன் வளரும் போது மாடு எப்படி பண்ணணும், எப்படி ஹேண்டில் பண்ணணும்னு தெரியும். வேற யாருன்னா வந்தாங்கன்னா அவங்களுக்கு தெரியாது. அவங்களுக்கு ஏரோப்ளைன் ஓட்டுறதுக்கும் புல்டோசர் ஓட்டுறதுக்கும் தான் தெரியும், மாடு ஓட்டுறதுக்கு தெரியாது. ஸோ இந்த மாதிரி ஒரு காலம் வரப்போகுது. சும்மா கதை கிடையாது. இதுதான் அவங்களுடைய குறிக்கோளா இருக்கு. நான் இப்ப சொன்னது அவங்க ஒரு அம்பிஷனா குறிக்கோளா வச்சு ஆராய்ச்சி எல்லாம் பண்ணிட்டு இருக்கிறாங்க. சக்சஸ்ஃபுல்லா ஆகுவாங்களான்னா கட்டாயம் சக்சஸ்ஃபுல்லா ஆகுவாங்க. தெர் இஸ் நோ டவுட், சக்சஸ்ஃபுல்லா ஆகும். இது உலகமே மாறி போயிடும். Fine. So you see, the story that I told you, the brain learns everything dynamically, not statically. After learning dynamically from the chip that is inserted in the brain, the body will start working as if an experienced person. That is one way. You provide the route to the routing table dynamically so that the packets can be forwarded to those routes when the packet wants to go. The other way is you write it statically. All the routes you need to write statically. See, any one of this way, you have to feed the routes to the routing table. Only then router can forward the packet. எப்படி அந்த ஆளுக்கு வந்து ஏதோ ஒரு வகையில அந்த விஷயத்தை பத்தி தெரிஞ்சிருந்தாதான் அந்த வேலையை செய்ய முடியும். அது நீங்க புக்கை பார்த்து படிச்சுக்கிட்டாலும் சரி, இல்லை சிப்பியை தூக்கி தலையில வச்சுட்டு தெரிஞ்சுக்கினாலும் சரி, பிரெயினுக்கு தெரியணும். அப்பதான் வந்து அந்த சூழ்நிலையில அந்த பாடி வந்து ரியாக்ட் பண்ணும். So body will react only if the brain knows how to behave in such situation. For that, you have books to read and know and learn and behave. The other way is insert the chip on the brain, and brain will know what to do when the situation arrives. Right. So the first thing is routing initial configuration. So we are going to have 1.1 routing initial configuration, router initial configuration, 1.2 routing decision, 1.3 routing operation. Three subtopics we have in this chapter 1. The first one is router's initial configuration. Before that, what is the function of a router? ஒரு ரவுட்டருடைய வேலை என்ன அப்படிங்கறத தெரிஞ்சுக்கணும். Where is the router going to be? In the network. What is the job of a network? To connect. Not only to connect, help communicate. So who determines the speed? Router, isn't it? Router. If router is slow, the network is going to be slow. Every router need to be fast enough equally. Only then you will have good speed. That routers we connect, no? The design is what we call as topology. See, let me repeat again. We have a lot of routers and we have designed the routers. We call that as topology. It's a network topology. Now, what is network? The network is nothing but the medium through which the traffics can communicate. When I say communicate, it will be a very small word. Today, network is not just for communication. It is also to do many things like voice, video, gaming, e-commerce, and much more. Telepathy, all is coming now soon. You need to just think in your brain. If you think in your brain, I will know what you are thinking. You no need to open your mouth and speak. Brain to brain interaction. Why? Your brain has got what? The chip. The chip is connected to the radio. Like your laptop and the router. It is talking right now. Do you see any communication, any sound between the laptop and the router? Silently they are talking now. If a laptop is not talking to the router, your router will not take the packet and send it to me. When you say yes, you opened your mouth and you spoke to the mic only. Who spoke to the router? It is the laptop. Very silently they can speak, no? Likewise, future is coming where people don't need to talk. You just come closer. In the brain, you give permission. Okay, brain can listen to me. That permission you give. Immediately, the port will be activated between you and me. Now, whatever you speak, whatever you think, not speak, whatever you think in your mind, I understand. Whatever I speak, you understand. So no need of opening mouth. It's coming. That is also topology only. Topology is going to be becoming very bigger in future. All will be connected through radios, Wi-Fi. So Wi-Fi is a logical topology. It's not physical, but there is also another meaning for logical topology. What is that? When you have many paths in the physical topology, there will be only one path by which the packet will be forwarding. That is called logical topology. So when we talk about network is responsible for various characteristics. Number one, it is providing a design, a physical design as well as a logical design. Number two, there is a speed determined by the network device. There is a cost involved. When you have a network, bigger size network, more costly. Security is determined. You can put password, you can encrypt, and you can make sure guarantee that the devices cannot be accessed by someone unauthorized, and also you make sure that the traffics go encrypted so that the data can be reliable, and then design the network in such a way that it is scalable. What is scalable? It can grow, it can expand and contract. That is scalability. And then availability. Network need to be available all the time. ஒரு கரண்ட் போச்சுன்னா டமால்னு இன்டர்நெட் போச்சுன்னா உங்களுக்கு கோவம் வந்துடும். வீட்டுல யூபிஎஸ் இருக்குது, ஆனா கரண்ட் போன உடனே இன்டர்நெட் போயிடுது. கேட்டா ஐஎஸ்பி காரனை ஃபோன் பண்ணி கேட்டா, என்னங்க பண்றது, எங்க ஏரியால கரண்ட் போச்சுங்க அப்படின்னு சொன்னானா ஒத்துப்பீங்களா? ஒத்துக்க மாட்டீங்க. கரண்ட் போனாலும், என் வீட்லயும் கரண்ட் போனாலும், ஐஎஸ்பில கரண்ட் போனாலும், நமக்கு பேட்டரி இருக்கு, லேப்டாப்ல யூபிஎஸ்ல பேட்டரி இருக்குது, we can still run. So give me the internet availability, always available. So design பண்ணும்போது we need to have some redundant devices, backup devices, backup network path. ஒரு path போயிடுச்சுனாலும், even if one path gets damaged, there should be an alternate path to reach the destination that will provide the availability. So who needs to guarantee all this? Your network. Your network needs to have a backup path to provide you availability. Your network needs to support encryption to provide security. Your network need to be designed in such a way that it is scalable. See, இந்த ஸ்கேலபிலிட்டிக்கு ஒரு உதாரணம் சொல்றேன். இப்போ எல்லாமே வந்து மாடுலார்னு பேசுவாங்க. மாடுலார் கிச்சன் கேள்விப்பட்டிருக்கீங்களா? மாடுலார் கிச்சன் பாத்தீங்கன்னா ஈஸியா கழட்டலாம், ஈஸியா மாட்டலாம். அதுதான் மாடுலர். ஈஸியா வந்து நீங்க ஆல்டர் பண்ணலாம். மாடுலர்னா அது வாய்ப்பு இருக்கு. ஃபிக்ஸட் பண்ணியாச்சுன்னா அப்புறமா வந்து ஆல்டர் பண்ணணும்னா உடச்சி எடுக்கணும். மாடுலர்னா கழட்டிட்டு அப்படி இப்படி கொஞ்சம் வேற சைஸ்ல வாங்கி அப்படி சொல்லிக்கலாம். ஸ்கேலபிலிட்டி அது. அந்த டிசைன் வந்து எப்படி பண்றோமோ அதை பொறுத்துதான் ஸ்கேலபிலிட்டி இருக்குமா இருக்காதாங்கிறது. மாடுலர் டிசைன் பண்ணீங்கன்னா ஸ்கேலபிள், தேவையானப்போ கூட்டிக்கலாம், குறைச்சிக்கலாம். மாடுலர் டிசைன் இல்லைன்னா ஃபிக்ஸட் டிசைனா ஸ்கேலபிலிட்டி இருக்காது. நெட்வொர்க்கிங்ல அந்த மாதிரி தான். ஈவன் இன் நெட்வொர்க்கிங் the design matters. If the design is proper, then network will be scalable. It can take more traffic. If the design is poor, with less traffic only, it will become tired. Scalability will be impacted. Right, we'll talk about these things. We have spoken about these things. I'll give you the presentation. You can read these things, okay? Availability, scalability, then go through these things, okay? Now, what is the router? Router is needed for routing. Routing between network is only possible through router, not through a switch. So if you want to connect from one network to another network, if you want to communicate from one network to another network, you need routers. Only through routers you can communicate from one network to another network. Not only that, you may have multiple paths. The best path is also determined by the router before the packet goes out. First, it will check the best path. Among all available paths, which path is best path? See, that's what we do now. Before we start our vehicle, we take the Google map and say, okay, Lalbagh, Bangalore. These are all the ways. I'll take this way. You pick one path among many paths. So before the packet is forwarded, before the traffic is sent, the routers will pick one best path among many recommended path in the routing table. So to route the traffic between the network, router is the device which is responsible for. And to do that, a routing table is used, isn't it? Now, how the routing table will be built? One, for the directly connected, it will build dynamically. For the remote networks, you have dynamic routing protocols or static route, isn't it?